Hey, Craig here. In this episode of Simple CNC Projects, we're going to make a brass fidget spinner. Okay, so to draw this fidget spinner in Fusion 360, I'm simply going to go up to Sketch, Rectangular, 2-point Rectangular, or you can just click anywhere and hit R. And I'm going to select this plane right here. Then I'm going to click in the origin point right there, drag down. Over here, I'm going to go 1.25 tab, and then I'm going to go 2.75 and enter. Now I'm going to go to Sketch, Fillet, select this point right here, enter 0.625, enter, repeat fillet, 0.625, enter. Alright, now I need to make the hole in the center for the bearing. So I'm going to go line, find the center point there, center point there. Then I'm going to go C for circle, find the center here. That's going to be 0.8661, which is 22 millimeter. Enter, enter. I'll delete this line. Now I'm going to hit the home up here, right click, press pull, select here. I'm going to go 0.2756, which is 7 millimeters, the thickness of the bearing. Enter. Now to make it look cool, I'm going to go to Modify Physical Appearance. I already have brass up here, but it's under metal down here, so I'm just going to drag brass onto here and close. So the parts I'm using in this project is machinable brass. This is 3/8 inch thick by 1.5 wide by 3 inches long. Actually it's 2.9 because I have a 12-inch length that I want to cut in 4 pieces. Also a 608 bearing. This is actually a hybrid. This is chrome. I wanted to get stainless, but I ended up getting chrome with ceramic bearings. We'll see how that works out. Actually got a 8-pack. My son rides a skateboard, so he gave me some Bones speed cream. It's not cream, it's actually oil. I'm going to end up cleaning the grease out of this bearing and putting this oil in instead. And I got this button. If I had a lathe, I could have just machined this, but I ended up buying it. This is a brass button. It just slides in there. It's the screw type. Like that. Alright, I got the brass from McMaster-Carr, and this piece here worked out to be about $8. You could probably find this cheaper if you go to like a local metal shop and they have some scraps and stuff. The bearings ended up working out to be $2.50 a piece. You could spend anywhere from like 50 cents, 50 cents, up to like $15, depending upon what quality of bearing and how long you want it to spin. The button, this was off of Amazon, the bearing. This, I don't remember how much that was, but that was off of Amazon also. So now I'm going to go into Cam, Setup, going to go into Stock, going to go to a fixed box size, and I'm going to set the width, or the X, at 2.9, and the depth, which is the Y, at 1.5. That's correct. The height, I'm going to put that at 0.375 for 3/8. On the model position on Y, I'm going to go offset plus Z. I'm going to over here, I'm going to click front, and I can see where my material is, my box size in relationship to the part. I'm going to set that offset at 15 thousandths, 0.015. Click OK. Now when I zoom in here, I can see there's 15 thousandths left right there. That's how much I'm going to shave off the top of it when I'm facing on the first op. Alright. Oops. I'm going to go back and edit that. I'm going to go to Setup, Model Orientation. That is correct. The orientation of the XYZ is proper. Stock box point. It's asking for the point where I want to set my Z's. I'm going to set my Z's in this bottom corner over here. I'm going to shift, push down the scroll wheel to spin it around so I can see it better. I'm going to select that point right there. And that's it. Click OK. Okay, I've gone ahead and double checked the jaw was all cleaned out, cleaned the bottom of this part. Now I'm going to set it on the upper jaw. Make sure it's seated down there. Feels like it's gripping pretty tight. Alright, now I'm going to go ahead and set my zeros on this corner back here and also on the bottom of the jaw here for the Z. Okay, now the first fidget spinner I'm going to machine is going to be at mini mill feeds and speeds. So I'm going to go to 2D face. I'm going to select my 3/8 4 flute, carbide, and mill. Okay. Now I'm going to double check my feeds and speeds in G-Wizard. I'm using my X2 mini mill profile. Set it to brass, carbide, 3 flute, 3/4. I'm facing, but I'm only going to be facing 10 thousandths and then 5 thousandths in 2 passes. So it's 10 thousandths at full width of cut. It's suggesting in brass 1800 RPM at about 8 inches a minute. So I'll go here, change this to 1800, cutting feet of 8 inches a minute. I usually just like to make these half. A lot of these aren't actually going to be used, but and go to geometry. It's already automatically selected the geometry. On my heights, stock top, bottom, model top. That looks good. On passes, I'm going to go multiple depths. The first step down is going to be 10 thousandths, and the finishing step down of 5 thousandths. And a feed rate. Select finish at, it's about the same at a higher feed rate. I'll just leave it the same. Okay, linking. Don't think I need to do anything there. Click OK. Go to the front, I can see my 2 passes right there. Alright, okay, I've loaded my code up. I've set my tool to tool 24. Double check the height offset on the height gauge. Did a sanity check to make sure my zeros are set properly. And ready to go. All right. Well, it turned out pretty smooth. There's a bit of a burr on the back edge over here. I went ahead and used the deburring tool to clean that off and clean off the other edges. Now the next step will be to mill this outer portion right here. To do that, I will go to 3D adaptive clearing. I will use the same tool, and I will double check in GWizard. Same settings, except I've increased my depth of cut to 0.25, which is approximately, I set it at 20 thousandths optimum load or width of cut, which gives me 1800 RPM at about 6.5 inches per minute at light rough. Go 6.5. I'll just put this at 3, 3, 3, 3. And my geometry is set automatically already based on the stock. And on my height, on my top height, I will put model top. And on my bottom height, I will put model bottom. The bottom is about 84 thousandths, so that should give me plenty of room for where I'm gripping it on the bottom. The soft jaw is 50 thousandths, so that gives me some room there. And I will go to the passes. I will put my optimum load at 0.020. Enter. Stock to leave. I will leave radial stock of 10 thousandths. 010. That's on the sidewall. Axial stock, I don't need to leave any axial stock there. Set that to 0. I'm actually going to, on my bottom height, I'm actually going to offset that by 10 thousandths of an inch, negative 0.010. It sets it down a little bit more. Click OK. And it looked like it actually gave us this inside part here too. Okay, well the ramp angle is only 2 degrees, so it should be okay. And our plunge feed rate is only 3, or ramp feed rate is only 3, so it should be okay. It's leaving 10 thousandths of an inch of stock on the walls here, so that should be okay. This internal diameter here has to be done carefully to make sure that the bearings fit in there snugly. So the finished pass here and on the inside will be done separately. Now I'm going to do a finish pass along the outside here. I'm going to go to 2D contour. I'm going to go at the same feeds and speeds. Geometry, I'm going to click this line right here. The heights, model top, selected contour, that's fine. Again, I'm going to go negative 0.010 ten thousandths on the bottom. Let's see, climb milling, no roughing passes, no multiple depths, no stock to leave. That should all be fine. Click OK. Now I'm going to do the same thing with the inside, but I'm going to take it on multiple steps. First I will select 2D contour, same feeds and speeds. I'll select the inside here. On heights, go model top, selected contour, again minus 0.010. On stock to leave, I've got 10 thousandths left there, and I'm going to take off 5 thousandths. So I'm going to leave 5.005. I'm not going to leave any axial, just on the wall. And the linking should be good there. Select OK. Oh. Zero. Click OK. Now I'm going to do the same thing, but I'm going to take this in multiple passes and kind of sneak up. So I'm going to have 2D contour with a 5 thousandths, then maybe make the next one 3 thousandths and 2 thousandths, and just kind of sneak up on it on different ops there. Okay, so I set the finish passes at, for the inside, the first will be 5 thousandths cut. The next will be 3, 1, and 1, basically sneaking up on it. There may be a better way to do this than I'm doing here, but I'll try this for now, and if anybody has any recommendations of a better way to sneak up on it, let me know. Okay, well, it went about 1/1000th of an inch or so too far, and the bearing went in there. I should have stopped at the last one, or tried to press fit it. So, anyways, I'm going to keep going. I'm going to turn this over. I'm going to flip it over, set my zeros again, and do the facing on the other side. I'll just have to, I don't know, maybe glue it in or something. It doesn't want to come back out. But there's definitely too much play in there to use it like that as a fidget spinner. It needs to be pressed in. Maybe I can glue it or something. Alright, so I'll flip this over. Face off the other side. And see what we can do about making it work. So my zeros on the jaw here are fine. I'm just going to reset my zeros on these two since it's actually moved, since it's smaller on the bottom. Okay, now that the first operation is done, I'm going to go on to the second operation. Click Setup over here. Go to Stock. Change this to Fixed Box Size. This will be 2.90. Y will stay the same, 1.5. Z was 3/8 or 0.375, but I took 15 thousandths off, so it's going to be 0.36. I'm going to offset from the bottom by 0. I'm going to go to Setup, and it's asking for the box point. I'm going to use my shift, hold my shift key down and the scroll wheel, push the scroll wheel down and hold, and rotate this back this way. And I'm going to be setting my zeros on this back corner over here. And I'm going to flip my Z by clicking on the arrow right there. And I can click the back button right here to confirm that's where I want it right there. See, I've got the stock, the extra stock on the top there. And click OK. Okay, now I'm going to create a facing operation for this setup. So I'm going to click 2D and facing. I'm going to leave the feeds and speeds the same. It's already selected the geometry. I can tell from my heights that I'm starting at 0.36, which is correct, and the bottom will be 0.2756, which is exactly the thickness of the bearings. So that all looks good, and I'm going to go to passes. I'm going to go multiple depths, and I'm going to go 10 thousandths depth of cut. And a finishing step down of 10 thousandths at the same speed. Transitions should be fine. They worked on the facing on the top. And that should be good. Okay, well there it is. Yeah, take it out of the vise and clean it up and see what it looks like. Okay, well I cleaned it up with some sandpaper, some 180 grit to take off the sharp edges on the inside and the outside. I don't know, I think it turned out pretty good looking. Of course, the only problem is the bore there is slightly too big. So, yeah, I mean, I guess it still kind of works. Yeah, but it's a little too loose. Yeah, it should be, I guess it probably should have been 1 thou less. Listen, it holds in there. Let me put the button on it. See how the final product looks. There. I have to hold it up this way because if I turn it this way, well, yeah, it tends to fall out when I hold it that way a little bit. I haven't cleaned out the oil and added the bones oil yet, but I think it turned out pretty cool. Alright, well the next one I'm making, I'm gonna make it at a higher feed rate. Alright, well if you like this video, I'd appreciate a thumbs up. If you have any comments, feel free to leave them in the comments section below. If you'd like to subscribe, there should be a subscribe button there. Also, if you'd like to support us on Patreon, there should be a Patreon link right there. I will be uploading the CAD file for this on Patreon. Alright,